So students, in today's video lesson, we will talk about our second colligative property, that is RLVP. RLVP means relative lowering in vapor pressure or relative lowering of vapor pressure. When it is a mixture or combination of two or three terms, that is number one vapor pressure, number two lowering of vapor pressure, and collectively it is now relative lowering in vapor pressure. So what is vapor pressure, what is lowering in vapor pressure, one by one we will discuss. So suppose first we have to discuss about vapor pressure. Remember students, vapor pressure is not a colligative property, or relative lowering of vapor pressure is colligative property, or lowering of vapor pressure is also not a colligative property. Means if we will talk about colligative property, then relative lowering of vapor pressure, the collective term is colligative property. So first, which is vapor pressure. So suppose we took a beaker which is half filled by liquid, and this liquid will form vapor, and this vapor will exert a pressure over the surface of liquid. That means here equilibrium is established between liquid and vapor. So why vapor pressure is not a Cp? Because vapor pressure is a equilibrium constant. Vapor pressure means it is a equilibrium system between vapor and liquid. Say, therefore its value means its value depends only on temperature, means equilibrium constant depend only on temperature, not depend on amount of liquid, surface area of liquid, volume or shape of the container. So therefore vapor pressure is not a colligative property. So next is lowering in vapor pressure, and here I mentioned for NVS solute. What is the meaning of NVS? NVS means non-volatile substance. So suppose in one beaker only solvent is there, that is H2O, and we know H2O formed vapor. And in second beaker we took solvent plus non-volatile solute, and NVS can be NaCl, like NaCl, KCl or sugar something. Here H2O will form vapor, but NVS will not form vapor, and both beaker are covered. So all solvent particle at the surface will escape, means they will form vapor and deposit at the bottom of this cover. But here at surface solvent as well as NVS solute will be there, and we know only solvent molecule will form vapor now. So here only escaping tendency किसके पास है? It is for solvent only. It is for solvent only. That means we can consider easily, or we can think that here vapor forming tendency is maximum, or here vapor forming tendency is minimum. Why? Because here all solvent molecule are forming vapor, but here only solvent molecule in spite of solute molecule, means solute is NVS, that means solute will not form vapor, only solvent molecule will form vapor. Therefore vapor pressure is maximum for pure solvent and minimum for solution which contain non-volatile solute, that means NVS, which not form vapor. Therefore Vp is collectively or respectively considered as less in case of solution. So here P naught vapor pressure of pure solvent, PS vapor pressure of solution, P naught is greater than PS. What is the reason behind this? Simply we can understand here. Here its meaning is PS is always lesser than P naught if PS containing solution containing NVS solute. Reason: some of the solute molecule will occupy some surface area of the solution, as I discussed now. Some of the solute molecule will occupy surface area of the solution. So tendency of the solute particle to go into the vapor phase is decreasing, means this solute particle will not form vapor ever, because it is NVS. NVS means non-volatile solute. So next, about lowering in vapor pressure. That means what? Lowering in vapor pressure means, simply we can understand, if big term, that is P naught. P naught is greater than PS na. If P naught is subtracting by PS, because P naught is greater than PS, then we will get lowering in vapor pressure, means kitna vapor pressure kam hua. It is equal to delta P. And further, if delta P is divided by original, means P naught, that means it is known as relative lowering in vapor pressure. Means when lowering in vapor pressure is divided by pure vapor pressure or vapor pressure of pure solvent, then it will consider as RLVP, relative lowering in vapor pressure. What is relative lowering in vapor pressure? Lowering in vapor pressure, that is P naught minus PS divided by P naught. P naught means VP of pure solvent. So here we will introduce one law, that is Raoult's law for NVS, non-volatile solute. According to Raoult's law, experimentally for NVS solute, RLVP is directly proportional to X solute. That means mole fraction of solute. RLVP is directly proportional to mole fraction of NVS in solution. And mole is a number na, which represent amount of substance. Therefore, RLVP is colligative property. So RLVP equal to P naught minus PS divided by P naught equal to X solute, or X solute is again mole fraction, N solute divided by N solute plus N solvent. So here one by one so many formulas we can calculate, we can design, we can form. And N solute equal to again given mass of solute divided by GMM of solute, and N solvent equal to given mass of solvent divided by GMM of solvent. So here if solute is lesser than solvent, that means very much lesser, means with respect to 1, if 0.1 is very much less now. So this term can be neglected. So new formula we can design, P naught minus PS divided by P naught equal to N solute by N solvent, because this term can be neglected with respect to this. Or we can reverse this equation, P naught upon P naught minus PS equal to N solute plus N solvent by N solute. Just reverting this equation. Or here solute can be common, then if we will shift 1, it will be minus 1, then again P naught minus P naught will cancel out. So new formula, PS equal divided by P naught minus PS N solvent divided by N solute, or P naught minus, just reverting this equation, so we will get 3 formulas, P naught minus PS divided by PS equal to N solute divided by N solvent. Simply P naught minus PS divided by P naught, here P naught minus PS divided by PS. So no problem, we can use any formulas and we will get answer on numerical portion. So P naught equal to VP of pure solvent and PS equal to VP of solution always. So summary will be there, that we have 3, 4, 5 formulas. One by one we discussed all these, and if solute is getting associated or dissociated now, so we have to multiply by want of factor simply. No issue if solute get associated or dissociated. Suppose it's 100% dissociated, 100% associated, or partial भी तो चलेगा, कोई problem नहीं है. We can use simply 1, 2, 3 formulas and we can design the numerical. So for numerical portion we will discuss in next video lesson. And remember, for osmotic pressure molarity is term, and for relative lowering in vapor pressure it is mole fraction. We have to consider mole fraction. Thank you. So dear students, in my today's video lesson we will discuss about some solved examples based on relative lowering in vapor pressure. And suppose we have a question in which 6 gram urea NH2CO NH2, molecular mass of urea is 60 gram per mole. We can calculate. Dissolved in 90 gram water. That means 6 gram urea is solute and 90 gram water is solvent. The substance which present in lesser amount is considered as solute and larger amount will consider as solvent. Given is vapor pressure of H2O is 50 mmHg. It is the unit of pressure, 50 mm mercury. Then we have to calculate vapor pressure of solution. that is PS. Lowering in vapor pressure of solution, that is delta P equal to P naught Vp of pure solvent minus PS Vp of solution. And third one, RLVP means relative lowering in vapor pressure of solution, that will equal to P naught minus PS means delta P divided by P naught, delta P Vp of pure solvent, PS Vp of solution, and P naught again Vp of pure solvent. So with this question we can understand three concepts: how to calculate Vp, how to calculate lowering in Vp, and how to calculate relative lowering in Vp. For all of these we have simple formula: RLVP equal to P naught minus PS divided by P naught equal to XB, and XB equal to mole fraction of solute, or X mole fraction of solute, where N solute divided by N solution, number of mole of solute divided by number of mole of solution, means number of mole of solute plus number of mole of solvent. Remember students, for RLVP we will consider only mole fraction concentration term, and for osmotic pressure we discussed with the help of molarity. That's why we have to introduce ourselves or prepare ourselves as we are perfect in concentration term. So let's start. This solution is very easy and we can solve one by one. Now put the value of P naught is 50, PS equal to, we have to calculate, again P naught is 50. What about N solute? Number of mole of solute. That means given mass of urea divided by GMM of urea, 6 by 60. And next N solute, it is 6 by 60. And N solvent, that means given mass of solvent, that is water, divided by molecular mass of water. So for as we will solve it, we will get PS equal to 50 minus 1, that is 49 mm mercury. And you can see how I calculated. Means PS is 49 mm mercury, Vp of solution. Now you can calculate lowering in vapor pressure, that is P naught minus PS. P naught kitna? 50. PS kitna? Now just we calculated, it is 49. That means lowering in Vp is 1. And similarly we can calculate relative lowering in Vp, P naught minus PS equal to 1 and P naught equal to 50. That means 1 by 50. So it's done. It's very simple numerical. You can easily solve. No issue regarding this concept, as I think. If any confusion, then you can message or call me. Suppose next example, here I took 5.85 gram NaCl is dissolved in 180 gram water. Calculate Vp of solution at boiling point of H2O. Means it is nothing but, just for confusing, boiling point of H2O is 100 degrees Celsius. And at 100 degrees Celsius, pure solvent, that is water, its Vp is 760 mm mercury. It is fixed and it will given in the question. No issue regarding this. Now what is the important term here? It is, we have to assume complete dissociation of NaCl. That means NaCl is dissociating. That means we have to put this formula, which is little change, we have to multiply by want of factor, that is I, simply. So for NaCl, I equal to 2, number of moles after dissociation, it is 2, 1 plus 1, and initial mole it is 1. So 2 by 1 equal to 2. Just put the value of I and easily you can solve as previously we done in previous example. Just 760 is P naught, Vp of pure solvent P naught, and PS we have to find That means 760 minus PS divided by 760. Put the value of 2, 5.85, 58.5. We neglected this term here. Why? Because 0.1 is very much less as compared to 10. And remember when we derived the expression for this, I told you when solute is very much less than solvent, we can neglect them. So here value of vapor pressure will be 50 as I solved. You can see, you can check, and you can message or text or call your problems regarding this. So I will give some numerical or some conceptual question for revision purpose in next day. Thank you.